Okay, in this problem here it says calculate the density, and the density, because it's a gas, will usually be expressed in grams per litre. So what this becomes is more or less a dimensional analysis type problem, and we're given the molecular weight, or at least we can find the molecular weight, and the SO2 molecular weight just off the periodic chart is going to be 64.07, and that's going to be grams per mole. Now the thing is, we need grams per litre. So what I would do is say, well, okay, we've got moles, those need to cancel. So I'll put the moles up the top here so those can cancel. I'll put litres down the bottom. And what I'd be left with is grams per litre. Which means now all I need is a relationship between moles and litres. Now since it's an STP, we know that 1 mole of a gas will take up this volume, 22.414 litres. So we figure that out, we'd come out to 2.858 grams per litre. Now the reason I've got 4 sig figs here is because I started out with 4 sig figs, and the number of sig figs is actually going to sort of depend on what you use for the litres here. If you use 22.4 you'd end up with 3. If you use 22.414 then this will decide the sig figs. We end up with 4 sig figs over here. Alright, so that'll give us the density of a gas at STP. Now this one down here, we're starting out with the density and we want to figure out what the gas is. Now in order to do that we're going to be looking for molecular weight. Alright, so we've got 0.090 grams per litre, and you see how I've written that. I've put the grams up the top and put a line and put litres on the bottom. Now in order to figure out which gas I've got, what I'm looking for is molecular weight. Now in order to get that I'm going to need grams per mole. So I'll put moles down the bottom, and I'll put litres up the top so the litres can cancel. Now the relationship here, because again it's at STP, is that 22.414 litres over 1 mole. And what that's going to do is it's going to give us our molecular weight, which will tell us which of these gases we're actually dealing with. It's going to come out to somewhere close to 2, which is the molecular weight for hydrogen.